Because when they're doing their proportional relationships, they're going to need to understand how to make an equation, make a table, and then make a graph.
Okay.
Representing the graph. So, and they're all proportional, so they're not too hard. Like this one here, I just put, Jim wants to buy trophies for the same teams in the City League. He found a company that sells trophies for $8 each. If X represents the number of trophies he buys and Y represents the total amount he spent, write an equation, table, and graph for the situation.
Okay.
So I just tell my kids, we do the underline, we do the marking the text.
Yeah.
So, I make them underline the important information, box the question, and then I know you have a different way of doing it.
I do the buck, like you underline, you box your question, you underline important information, you knock out anything and circle vocab.
Yeah, that's exactly what we do.
Yeah.
And so then I just make a graph. It only has to be a graph of the first quadrant. And I tell them, I ask them, why can't you have negatives? And, sometimes they don't know. Sometimes they'll say, well, because you can't have negative trophies. And I'm like,
Yeah.
Exactly. So with our proportionals, it's all pretty much. And it's really, really important to make sure that they label their graphs, because that's something that they don't do, and it's something they need to do.
And they just forget which ones go where.
Exactly.
Yeah.
And so what I do is I tell them, you gotta make a line for your equation, make it just a T-chart. That's all you really need, and make a graph. So okay, now we got to put this into form. And so it's hard to do the equation at first. I make them do the table first.
Okay.
Because I say, okay, I said, and I tell them too. I said, what are you doing in this? Are you trying to answer a question? And they're not. I said, this is just giving you information.
Yeah.
What you need to do, you're not answering a question. What you're doing is you're giving information, and you have to just represent it in 3 different ways. I said, so you're not really answering anything. You're just representing. So I said, okay, so let's do the chart. Now, it says here X represents number of trophies. So what if Jim bought 1 trophy? How much money is he going to spend?
$8.
$8, because each trophy costs $8. So what if he bought 2 trophies?
16.
16. All right. What if Jim thinks the trophies are ugly and he doesn't buy any of them? How much do you spend? 0, right? So you can just create data that way.
Yeah.
And then with this data, I said, this is where I start introducing how to write an equation. I said, I always tell them that, your equation is always going to be y equals and then kx, where k is your constant of proportionality or your rate of change, because they're pretty much the same thing.
Yeah.
So I always tell my kids, when you write an equation with proportional relationships, always start it off with y equals blank x. And something's going to have to go in that blank.
Yeah.
And I say, well, what is it? And I say, well, what I do is I look at my table. So I kind of introduce this. They're going to see it's 8. But I tell them, okay, what do you multiply to 1 to get 8? 8. So I put that times 8. What do you multiply to 2 to get 16?
8.
You get 8. Can you multiply 0 by 8 and get 0? Like, yes. So this right here, this number in the middle right here, that's your constant number. It's always there. It's always 8, 8, 8. No matter what you do, it's going to be 8.
Yeah.
So this is your constant of proportionality, which is your k. So your 8 goes in front of the x. So that's the way I explain it.
That's a good way.
And then sometimes these will be fractions.
Very visual.
Yeah, and I'll show you how to do that when it's fractions, because the fraction ones are a little bit trickier, but not too bad.
Yeah.
Then I say, okay, now you got to put it on your graph. And so if you look at your x's, you go by 1, 2, and then 0. I said, so your origin is always 0. You know that. So I would make my x-axis just go by ones. 1, 2, 3, 4, 5, 6, and so on. And I said, but if you do your y's, what should you go by on y's? If you look, you go from 8, 16 to 0. I said, if you go by ones, your y-axis is going to be way too big.
Up there, yeah.
I said, so you got to think about what you can go by. And most kids should say, oh, well, you go by 8s because they, count by 8. So you just go 8, 16, and just so on. And then, how come I can't think? 24, 32, and then 40. So now I tell them, okay, now you're going to have to plot your points. So if you look, if you buy 1, and I also tell them this, I forgot to say this. What do you label your graph by? You just have numbers, but what do the numbers mean? This is where it's important that they really make sure they label.
Okay.
Because they're going to have to look and say, okay, well, what does the x values mean? And if they're looking around, they're like, I don't know. I said, well, read the question. You underlined what it meant, because x represents number of trophies. So just make sure they label number of trophies here. And then for this, what does y represent? It's just the total amount spent. So I just put total spent. And one thing in high school, I don't know why, they're really big into making sure they use units. So I'm telling them now to use dollar signs because your total spent's in dollars. Because you could be in Japan and using yen or using Mexico using pesos.
Long as they put...
So just put the units. The units is very important. And once they do that, so they, if you buy one trophy, it costs $8. So you put a point there. 2 trophies is 16. Put a point here. 0 trophies is $0. So you put a point right there at the origin. Now, this is the part everyone's gonna want to just draw a line, right? Everyone wants to do that.
Oh, you want to? You got to connect the dots.
Exactly. But you got to ask them: do you connect the dots or do you not connect the dots? This is the one thing that everyone just draws the dots, and you got to remember that. When do you draw the dots? Why? I mean, when do you draw the line? Why do you draw the line? And I say, if you draw a line, this is what I tell my kids. If you draw a line, this is what this means. You can go into the trophy store and say, excuse me, I want to buy that trophy. Like, okay, but break the arm off and say, I only want to buy the arm. And you can't do that.
No.
Because you can't buy a fraction of a trophy. So you can't have anything in here because those are all fractional parts of one. And you can't, but you have to buy one trophy. You have to buy two trophies, 3 trophies. You can't buy 2.5 trophies. Doesn't make sense. Even if you're going in and buying a shirt, you can't go in, rip it in half and say, I only want this half. So you can't connect the dots. And I bring in that vocabulary of discrete. I tell them that's a discrete graph because each point is individual. You can't connect them. And so, I mean, that's not really 7th grade stuff, but if they start to see that now, it'll start to make more sense.
It'll make more sense even, and it's prepping them for you.
And so that's kind of how I teach that.
Okay.
And you'll be surprised at first. They're like, "What is that?" And I say, "Okay, you try one." And I make them draw the the line, the XY chart, and I say, "Okay, here's the skeleton graph." I also when I do the graphs, I always tell them something stupid, but I tell them this is like the bones. I said, think about it. If you go when you find a skeleton in the desert, you don't know what it looks like. He's a skeleton. Everybody has a skeleton. That's what that is. You got to give it some meat, and this when you label it. That makes the bones actually mean something because then you can picture what the person looks like. And I tell them that, and they're like, "Oh, okay." So it kind of makes sense to them a little bit.
Yeah.
And then I tell them, "You guys try, and if you have trouble, work with your group or then try to do one, and you'll be surprised how many will get it right the first time."
Cool.
And then they won't really believe it. They're like, "No, is it really?" I said, "No, it's right." But look what you did when you do this. You created an equation. You made a table, and you drew a graph, all in one problem. And those 3 big standards that they need to know for proportional relationships. And so that's why I do this, and we do it a bunch of times. And then what I'll do is then I'll give them a table and say, okay, now you got to make an equation out of a table.
Oh, okay.
So, they may have a table like this, for example. If they got a table like, let me think of a good one. Like, let's say like 2, 5. Okay, so they have something like this. And see, remember over here where we went, 1 times 8 is 8, 2 times 8 is 16, 0 times 8 is 0. But what do you multiply to 2 to get 5?
You're going to be doing fractions in
exactly.
this one.
So what we have to do is I said, okay, well, how are you going to find that constant, rate of change or that constant proportionality when you got this?
So wait, is this how you introduce the fractions to them?
Yeah.
Okay, okay.
So then I said, okay, so how do you do it? What do you do? And I said, okay, look, this is what you do. I said, first of all, you ask yourself, what number do you add to 2 to get 4? You add 2. What number do you add to 5 to get 8? You add 3. Okay? And then I tell them, okay, I said, we have K here. And I kind of pre-teach this before. But I say K is always equal to the ratio of the change in Y over the change in X, where Y is always on top and X is always on bottom. So if you look, here's your Y. What's your change in Y? Change in Y is 3. What's your change in X? Your change in X is 2. Can you reduce 3 over 2? No. So your answer is Y equals 3 over 2X. And that's your equation.
Oh, they're going to like that.
Does that make sense?
Yeah, that makes sense. And that's going to be something that they're like, once they do it a couple times, they're
They
going to be
get
like,
it.
this is so easy.
It's very easy. Yeah. Even you can do it here. 8
Yeah.
plus 8 is 16. 1 plus 2 is 8. So what's 16? No. 1 plus 2 is 1, not 8. So what's 16 divided by 1? It's 8.
Yeah.
So it works every time. This way will work even if it's non-proportional. And this is what I'm trying to teach them, because all we're doing is finding the slope
Yeah.
in a simpler way, instead of using the y2 minus y1
Super
over
cool.
x2 minus
That's
x1.
really cool. I've never learned it that way.
So, but-
it's,
And that's
I
what
like
I
that.
do, and that's how I teach my proportional relationships. And it's just, that way definitely is a simpler way. But once you get through unit rate, I would go straight into this. Because once they go into this, then you could say, okay, once they do this, then you can give them a table and say, okay, find the rate, make an equation out of the table. Once they do this, you can say, okay, well, look, you went, teach them rise over run.
Yeah.
And you go up 8 and to the right 1, that's 8 over 1, it's the same there. And then you can give them a graph and say, okay, from this graph, make an equation. And when you connect it like that, that's when all that stuff will kind of fall into place, and they'll realize that the equation, the table, and the graph, they all mean exactly the same thing.
That's so
It's
cool.
just a different representation. So that's how I teach
I think
it.
I have all that graph paper. from the other
Exactly.
day on the side. Well, I'll take that. Oh, cool.
So does that make sense?
No, it makes total sense.
Did I go too
love
fast,
it.
or is
Nope. Nope, I love it.
Okay. And if you want this
I'm
worksheet,
gonna
I
grab
have,
this worksheet.
and I
from you.
have it in my room. I should
Yeah,
have brought you a copy too.
No,
I
I'll
have it
grab it
right
from
now,
you
so.
today or tomorrow or wherever, whenever.